Hey, Algebra 1. This video covers the basics of slope as well as how to define slope on a graph of a linear function. So the first basic definition we have for slope is like we have right here on the first screen. Slope is considered a rate of change. Okay, so we take a segment of our domain, which is all of our x values, and we see how much it increases or decreases by in terms of y. That gives us a slope. Slope is also considered, an easy way to remember, is rise over run. Okay, we'll talk about that in a little bit so we have a better idea of what that means. When we talk about types of slope, we can have a positive slope where the further right we go, it slopes upward, and so it goes up and to the right. And likewise, when we have a negative slope, the further right we go, the further down we go on the line here. Okay, so it goes down and to the right. Okay, just like we have special solutions and equations, we also have special cases of slopes. A zero slope looks like this. Okay, so we would call this a constant function rather than a linear function, but it still produces a horizontal line. On the other hand, an undefined slope looks like this. It's a vertical line, and we'll talk about why an undefined slope looks like this in next examples. Okay. So let's take a look at some graphs here just to get us started. So let's say we have this line here. Remember, we want to think of slope as rise divided by your run. It's a ratio. Okay, so we look at how to get from the first point here to the next point over. Okay, so we start at the first point, go to the next one. We have to go down 2, so that's a value of -2 divided by how far on the right we have to go. Well, that's +1. So in this case, -2 divided by 1 would be the slope of this one, this line, or we could think of it as just -2. Okay. Looking at a second example here, we have a different line. I'm going to draw this out, blow it up a little bit bigger so you guys can see it. So we have a slope that looks like this, one point to the other. Once again, getting from the first point to the second one, we have to go down 1, so that's -1, and then over 1, and that's +1. Okay, so then that means our slope for the line is going to be -1 divided by +1, or just -1. Okay, and once again, we can kind of keep that pattern up if we go down and 1, down and 1, or if we start at any point on the line and go down 1, down 1, down 1, down and 1, we can see other points that are on this line as well. The last example I want to look at is this one right here. Okay, once again, rise over run. So going from the first point to the second point, we go up 1, 2, so that's a rise of +2. And then a run of 1, 2, 3, 4, 5, and 6, so +6. So 2 divided by 6 is my rise over run. But sometimes we run into problems like this where we have to simplify our fraction, make it a little bit easier to work with, because we want to work with smaller numbers rather than larger numbers. So these both have common factor of 2. So if we divide both of these by 2, we get our slope, or our rise over run, is 1/3. Which means that I can go up 1 and over 3 and still end up at every point that's on this line here. Okay, so stay tuned. We're going to take a look at a couple other ways we can find slope in a line.